here's proof. This is the proofs we're going to do today, I think, are like ridiculous easy proofs. They really are. All right. And I think you'll agree. My first period class, I said that at the beginning. They're like, "Oh yeah, I hate proofs. They're so hard." Da, da, da. But then I asked them after we did these proofs at the end, and they're like, "Oh yeah, they were easy." And they all agreed with me. Okay, so I think you'll agree with me as well. So let's take a look. Let's mark some stuff first. That's the first thing I do when I see a proof. Here's the given information. Here's what we're trying to prove. Here's our picture. So I'm going to take all the stuff that they give me, I'm going to mark it, and then I'm going to look at it and see if there's anything else that I can figure out just by looking at the picture. Okay? Do you hear what I said? So I'm going to mark the stuff that's given, and then look to see if there's anything else that I can mark just by looking at the picture. And there might be. Sometimes you can't, sometimes you can. So let's mark the stuff that's given. AB equals CB. So AB equals CB. Mark that. AD equals CD. There's AD, there's CD. Let's mark that. So that's what we've got so far just from the given. Now let's review just a little bit. How we've got two ways so far. We're going to learn some more, okay? But so far we only have two ways to prove that triangles are congruent. What was the very first way that we learned that triangles are congruent, Alex? Side, 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 okay? And then there's another one. What's the second way, Alyssa? Side, angle, side. And there's some more that we're going to learn a little bit later on, all right? But so far, that's all we've learned so far. Side, 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 and side, angle, side. You got it? So let's take a look at this. What do we have so far? Well, I've got a side and a side, don't I? Now, do you think I can go side, angle, side? Is there any way to show that angle A is equal to angle C just from this information right here? What do you think? Nah, but this is not equal to this. Okay, so because this one and this one are equal, it doesn't mean anything as far as this angle or anything like that. Taylor, what do you think?
Well, since BD goes with both of them, it would equal itself.
Exactly. Exactly right. And I think we've talked about this once before. We didn't spend a lot of time on it, but we talked about it briefly. You're absolutely right. I like how you said it, that BD goes with both of them, doesn't it? BD is part of this triangle on the left, and BD is part of this triangle on the right. So, I could do this. See? Even though it's one line segment, it's still contained in both of those triangles, isn't it? So, BD on this triangle is equal to what? BD on this other triangle. Agreed? And there's actually reason for that. And I think I might have talked about this. Remember we said this? There's actual property, there's an actual rule. That's right. Okay, when I have something equal to itself, I actually have a property that explains why that is true. And the property is called the reflexive property. And we're going to use that quite a bit. And you're going to like it, okay? It's like, the way I just said that, it's like, and you're going to like it, okay? I mean, seriously, you will like it, okay? It's not like, all right, kids, we're going out to the whatever, and you're going to like it. You know, your parents ever say that?
You got to add in that
or else. Okay. But I'm serious. It didn't really come out the way I meant it to come out. But you will like the reflexive property because it's really easy to see, it's really easy to use, and it just kind of just pops up right in front of you and you're like, oh yeah, there you go, reflexive property. So that's the reason why A is equal to A. So I could say that BD on this triangle equals BD on this triangle for what reason? Reflexive property. Now, do I have enough information to prove my triangle's congruent now? I absolutely do. Look, there's one set of sides, right? One pair of sides. There's another pair of sides. That's two sides. And look, and I got this side right here is equal to itself. I guess you could consider it as a pair, even though it's only one side, right? So look, I've got side, and guess what? I've got side. So these triangles are congruent because of side, side, side. It doesn't get a whole lot easier than that. Don't think they're all going to be that easy, all right? But we got to start somewhere, right? And that's where we're at. Let's do this. Let's make a two-column proof. Remember what I said before? The book sometimes says write a flow proof. Sometimes they say write a paragraph proof. And sometimes they say write a two-column proof. What did I say that we're always going to write? We're always going to do the two-column proof. Even if it says write a paragraph proof, I still want to do it as a two-column proof. Is that all right? All right. Now, there are reasons. At least at first, we're going to do them as two-column proofs. All right, so we've got statement on one side, and we have, actually put S, and we have reasons on the other side. We always have to back up what we say. All right, that's what they want you to do. They always want you to back up with some facts on why these things are true. So let's do this. A lot of times people think, well, you always take the given and you always put that first. And I tell you what, most of the time, I'd say the vast majority of the times, sure, that's what you would do. You'd start off with your given. There are times, maybe not today, but a little bit later on, there are times when you don't necessarily want to start with the given. Maybe you want to start with something else. It all depends on your proof. I was looking at YouTube the other night for people doing proofs and things like that, and that's where I actually got these proofs from. Teachers would put them up on YouTube and go through them and stuff. I'm like, oh, I'll use those instead of the ones in the book, just to be a little different. So one guy, like, first thing he said was, okay, always put the given first, and he always put the given first. Before he even explained the proof or did anything, he said, always put the given first. I don't really like that. I look to see what I want to try to do. What am I trying to show? I'm trying to show that this side is equal to this one's equal to that. Now, where do I get those two sides? From the given, right? So really, where do I start? I start with the given. If I wanted to, I could start with this one right here. Couldn't I? I could have started here. I didn't have to start with a given. I could have started here. What would my step be? BD equals BD, right? Because of reflexive property. That could have been my first step. Would you agree? All right? But a lot of times we use the given, so we might as well go ahead and do that. So AB equals CB. Now watch what I do. Right, I like to do that. Okay, you remembered. So I like to put a little S there because that represents my side. You don't have to. You won't see that in the book. I don't know if anybody on YouTube does that. I just made that up myself. Just because it helps me organize things a little bit better. So I just put an S there to represent that's one of my sides. Do I have another side? Yeah, AD equals what? CD. And that's another one of my sides. So I just put a little S right there. I think it's helpful, don't you? All right, and that's all because they're given. They number these steps. You don't. Oh, yeah, I don't care if you number them or not, but a lot of times they number the steps. So that's step number one. Even though there's two things, it's all given, so we just call it one step. You okay with that? All right, step two. What do you think the next thing? I've got this side. I got this side. What's the next thing I want to go to? Very good. So now I'm going to go BD equals BD. Right? Now, why does BD equal BD? Reflexive property. So just write that down. So it's the reflexive property. That's easy to see, isn't it? When something's equal to itself. Yep. So there you go. And that's my other what? That's my other side. See why I like doing this? Because now I can just look down the column and say, oh, side, side, side. So now I'm ready to do what? Now I'm ready to show that the two triangles are not equal, congruent. Right, I'm ready to show the triangles congruent to each other. So this will be my third step. And that's what I want to prove anyway, isn't it? All right, so triangle what? ABD is congruent to triangle what? CBD. Good. All right, and what's my reason? Side, side, side. But we write it SSS, but we say side, side, side. Again, I was looking at YouTube. It's funny how different teachers teach different ways. You know how, what did I say about this? You say what? Side, side, side. We don't say SSS. I actually saw a lot of teachers on there, and the teachers actually say, what do you think? SSS, right? The teacher's like, okay, why is that? It's because SSS. I'm like, ah, don't do that. But I also heard another teacher on here. He said exactly what I did, you know, and I didn't say it because I heard him. He, you know, that's the way a lot of people, he must have heard me, exactly. But he said, yeah, we write SSS, but we say side, side, side. I'm like, that's exactly what I said today, you know, and I get all excited. That's right. I do. That's all I ever do. Yep. My whole life, that's all I do is just go on YouTube and watch math videos. Yeah.
And old show medicine.
And a little bit of old crow medicine show, right? When I take a break. All right. Or when I'm taking a break from watching Old Crow, then I'll watch some math videos. I'm just kidding. It's not what I do, okay? I'm just joking.
The average life of this whole
I believe it. I know. You guys probably think the only thing I ever do is sit around and do math problems and watch math videos. Well, I don't.
And you do yearbook.
Yes, I do. I do a lot of things, okay? A ton of things besides do math. All right, that's good enough for that. Let's do another one. You ready? Okay, here's another triangle, and we're going to try to prove these two triangles congruent. Let's find the triangles first so we can get a general idea what we're trying to prove congruent. So FGD FGD. That's this skinny one on the left here. And IHD, that's the skinny one on the right over here. Do you see it? So it's the triangle on the left, the triangle on the right. We're trying to prove that they're congruent to each other. We have two ways to do that so far. We have two ways, don't we? Side, 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 or side, angle, side. Good. So let's mark the stuff. Look at this. Triangle DGH is isosceles. What does it mean for a triangle to be isosceles? Yeah, two equal sides, right. So DGH, which one is that? That's this middle one right here. DGH is isosceles. So and we have to make a little assumption. It doesn't look like that and that one are the ones that are equal, does it? So I'd say this one and this one. We have to make a little bit of assumption on that, but that's okay. All right, so those two sides are... Now, are the two sides given to be equal? No. The triangle is given to be isosceles. What did we figure out from the triangle being isosceles? That the two sides... Now, why? If this is isosceles, that's what they told us. How did we know that this side and this side were equal to each other? It's the definition. Exactly right. It's the definition of isosceles triangle. We use that a lot. Okay? We use a lot of properties. We use a lot of definitions. We use theorems and postulates and stuff like that. So this is one of the things we're going to use, is that the definition of an isosceles triangle. Let's do the rest. DF equals DI. DF is this one right here. DI is this one right there. So far, I've got two sides equaling two sides. If I knew the third sides were equal to each other, then they'd be congruent because of side, side, side. But I don't know anything about FG and IH, do I? So let's figure out what else. FDG, angle FDG. FDG, that's this one way up here. And IDH, IDH is this one right here. They're equal to each other. Now take a look at it. Now you can tell me something about the two triangles. They're congruent, aren't they? Give me a reason. Side, angle, side. Remember, the angle has to be between those two sides, okay? So side, angle, side. And there we go. We're basically finished our proof. How's that? It's pretty easy, isn't it? Let's write it out, and we'll be done with this. They basically gave us everything. We only had to figure out one thing. What was that one thing we had to figure out?
The isosceles.
Right, the whole isosceles thing. All right, so here's our statements, and here's our reasons. Let's do this. Let's do this. Let's go like this. Let's go this side, this angle, this side when we write it down. Is that all right?
Yep.
So why is this side equal to this side? It's given. So let's do that. Okay, so it's FD, or they write DF. We'll write DF is equal to DI. Why is that true? It's given. Now what is that? That's one of my what?
Side.
One of my sides, okay? So that's one side, and that's given. Let's go side, angle, side. So let's go to the angle now. All right, so why is that equal to each other?
Given.
That's given as well, isn't it? All right, so angle what? IDH. Now what is that? That's the angle, isn't it? So far I've got a side, I've got an angle. Now I want to show the other side. Can I go right to DG equals DH? Because they don't give me that, do they? I had to know something before I figured out that DG was equal to DH. What did I have to know before that?
You have to know that they're isosceles.
That's right, that the triangle was isosceles, right? It's an ugly looking triangle. DGH is isosceles. Isosceles, right? Spell that a few times, you'll remember it. And why is that? Why are all these things true?
Definition.
No, they're just all given. They're all given. Okay, so all three of these are given. Now, there's my side, there's my angle. I'm still missing that other side. So now I got to say that other side. So now I got to say DG is equal to what? DH. Now I have to have a reason for that too. Why? Definition of isosceles triangle. Okay?
Okay.
It's pretty easy, isn't it? What did I just find right there? That's one of my sides, isn't it?
Yeah.
That's one of my sides.
Yeah.
So look, I've got a side, I've got an angle, I've got a side. So what can I now say about these two triangles? That they are congruent to each other. IH. I know. And why are they congruent to each other?
The side.
Side, angle, side. We don't say SAS. We don't say SAS. We say what? Side, angle, side. All right. We got some time. Let's do another video because I want to explain something else.